All right, now what if the angle is not given? Can we still use a triangle to find an angle? Yes, we can, as long as we're given two sides. Remember I said there's going to be three pieces of information. I always will have to give you two. So if I'm asking you to find an angle, well, then I'm going to need to give you two other pieces of information, and those would have to be the sides. So let's take a look at this one. Find the unknown angle D. So D is our perspective. That's awesome. They've given us the perspective of D. So I am going to label this. Now, opposite there is the hypotenuse, so I can label that immediately. Now, from my perspective, if I go there, the opposite direction, I will see OPP, opposite, and of course this side is the adjacent. So now I'm going to need to take a look at what I have. Well, I have this H, and I have O. O and H. O and H. Well, that is sine, because it's so. And that's partly because we're in the chapter that's titled Sine. So all of these questions will be, but I'm just still going through the procedure that you would have to go through. So this means that I've got a formula. Sine of some angle equals opposite over hypotenuse. So now I have three pieces that I need to find. Is that, or not I need to find, but there's three things. There's that, and there's that. Opposite, hypotenuse, and angle. Now it says in the question, I believe, find the angle. Okay, well that's this. That's theta. So I need to find that. So let's fill this in. Theta is the angle, and it says D, and yep, D is my perspective. So I'll put D, sine of D, equals opposite, which is 30 over hypotenuse, which is 100. So sine of D is equal to 30 over 100. Well, that's the same thing as 3 over 10, which is the same thing as 0.3. Okay, so what we're going to need to do here is you're going to need to work backwards. And you can take a look at your trig table, and you can find 0.3, and you can go back and find the angle. The other way of working backwards is saying, okay, I will instead do sine backwards as a -1. We call it inverse, sine inverse of 0.3, and that will get us our D. That's what we're doing here. Now the algebra behind it is actually, and I won't do this all the time, but technically if you want to get rid of the sine, what you need to do is to do sine inverse on both sides. And 0.3. So I did sine to the power of -1, or sine inverse, of both sides, and that crosses out. Those signs cancel each other, and I'm just left with a D equals sine inverse of 0.3. Now we generally don't write the sine inverse both times, so we just say, well, if we're trying to find the angle, we're going to go the inverse way, and we already have the 0.3, so we can work backwards on our chart, or if we have a calculator, we can go the opposite direction. And I'll show you that on a calculator now. Okay, so 0.3, so I can go 0.3, and then I need to get the sine inverse. So most of the times it just says sine, cosine, tangent, but there's usually a shift button or something. So in this case it's the arrow. So sine inverse is 17.457. So 458. 17.458. If I'm going to 3 decimal places. Degrees, because we're now finding the angle, and the angles are always measured in degrees. So that is a huge adjustment. We have to find the angle, and angles have to work in an inverse direction. We have to kind of work backwards. We have to undo what we did. So we can work backwards on a table. We try to find 0.3 on the table, and then it allows us to find an angle. Or we put 0.3 into a calculator, and then we have to invert it with the sine to do the inverse sine button. So let's try this again. And we're going to get more practice when we do cosine and tangent as well. But here we have, okay, so like, say I'm just looking at this right now. I'm like, well, I need to choose a perspective. It's like, I can't choose that. There's no information there, and there's no information there. So you're like, well, what am I going to do? Except that we have to just read the instructions. It tells us to find the unknown angle D. Okay, well, I have to choose that, so that will be my perspective. So the hypotenuse should be very easy to spot. It's always opposite the 90 degrees. So that's hypotenuse. Now, from your perspective, you can go over here. That's opposite, leaving the last one here to be adjacent. So let's take a look. We're given some information for hypotenuse, which is H, and we're given some information for opposite, which is O. So I'm looking for a formula with O and H in it. So how much room do I have? Yeah. So maybe I'll do here. O and H. That's what I'm looking for. Well, that's sine, which is why I said before we're in the sine section. So you start off with your formula, sine of some angle equals O and H, so opposite over hypotenuse. Now, sine of some angle, we're not given that. So the angle is just D. Opposite was 25 and hypotenuse was 100. So sine of some angle D, 25 over 100 is the same as a quarter. And a quarter is the same thing as 0.25. So 0.25. So sine of D equals 0.25. So again, we're going to take a look at a table and work backwards, or we're going to use a calculator. So let's take a look at the table first. So we're trying to find the angle. So this is what the table would look like. Now the angles are in degrees. Now we're looking at the sine column here. And we're trying to find the degree, and it has to match whatever our answer is here. So the angle is unknown, but we have the result. The result is 0.25. So we can take a look at the table and see if we can find 0.25. And here it is. So it's 0.2588. So 15 is a bit of an overshoot, and 14 is a bit of an underestimate. So it's somewhere between 14 and 15. Okay, well let's see here. Sorry, let me try that again. I want to see 0.25. Okay, yeah, so it is between 14 and 15, but which one is it closer to? So this is 25, and then there's 88 above it, and this is not 25. It's underneath, but it's only 81 below it. 81 plus 19 is 100. So it's actually more closer to 14. So my guess here is, well, it's almost halfway in between. So it is 14.5 degrees estimated, but it is a tad closer to 14. So we could, if we needed to actually round up or round down, we could say 14 degrees, though it is really, really close to being in the center. So 14.5. Now let's try this with the calculator. You're trying to find the angle. Let me just erase this here. So we said 14, 14.5, somewhere around there. Now, in order to get rid of the sine, the algebraic way to get the D alone, you're going to have to do the sine inverse. Remember I said I wasn't going to write it every single time, but apparently I don't listen to myself. So I did the sine inverse of both sides, and that way sine and sine can cancel out because the sine inverse cancels the sine, and you're just left with a D. And now you got to put this into your calculator. So 0.25 sine inverse. So 0.25, and there's a sine inverse button, and I get 14.477. So 14.477. Was that rounded correctly? I'm just going to check again. 478. So that is also an estimate because there's so many decimal places, and I've just chosen 3. So if you use a calculator, I always say use 3 decimal places. If we're using a trig table, then I'm okay if you go to the nearest degree, in which case you're estimating at 14 degrees. Now if you do 15, that's technically not right. You've routed incorrectly, though you are really close. So just keep all of that in mind. Okay, so that's how you do it backwards. If you're ever missing the degree, so if you need to find the angle, which is the degrees, you need to go backwards on the table, or you need to do sine inverse. Okay, so keep those in mind. Those are your two options when looking at these things. Okay, so I think that's it. I will just zoom out here for anyone who needs to take a look at this stuff. And in the next, we'll do the exact same thing in the next one. However, we're going to be using cosine and sine, cosine and tangent as well. So we're kind of mixing everything together.